Welcome, Hornets. In in this video, we're going to be talking about the difference quotient and how it works, what's going on with it, and why we are using it. This is where we begin our calculus. And what I'd like to just talk to you about is what is the difference quotient? So the whole idea is we are making slopes. So I've taken a piece of thread here so that we can clearly see what's happening. Now, if I put this piece of thread on the dot for 1 and I go all the way up, you'll notice that what I'm creating is the line of a slope. Now, as we move, so keep in mind we're sitting right there at 1 for one of our points, and the other point is up at the top at 2. Now, if we are using our delta x, so delta x means the change in our x value, okay? And if our change in x goes smaller than 1, so you'll notice I've got another dot here at a half. And you'll notice I'm creating a slope there. And then I go down to, 3/4, or 1/4, excuse me. And then I go even further than that to about 12. And you notice I'm slowly approaching a tangent line. Okay, so if I go to the other side, I put it on 0. And then I go to 1/2. You'll notice it's also approaching that tangent line as the delta x gets closer and closer and closer to 0, which means that from both sides, we have two slopes that are approaching, let me see if I can do this, approaching the same value, okay? So what we were looking at was a slope that was coming down on our graph, and the other is going up. So if I can show that, they're approaching like so, okay? When we reach that one point where our delta x is so small that we can't even tell the difference between the 2 points, we're at the tangent line. Now, if you take a look at the numbers on this, you'll notice what's happening with my slope. In this, I'm going to just go ahead and turn off this light right here so that you can see it clearly. You'll notice in this, I have created a situation where I've found my delta x, and I found x and y for both -1 and -2, and I'm utilizing the formula of the difference quotient. These are the slopes that I am approaching. So each of these slopes between our x1 and our x2, x1 and x2, x1, x2, using this formula. And you'll notice that my slopes are going from -3 when I was looking at the slope between -2 and -1. And look at that, they're approaching 2. So one can surmise that at x equals -1, when we are sitting on that tangent line, when the slope of the graph has come down, just go ahead and look at it again, has come down the graph, okay, to that tangent line on this side and on the other, has come to the tangent line on this side, that tangent line, as you can see, is going to have a rise over a run or a slope. That's what the difference quotient finds. The difference quotient as a limit, okay? So as a limit, finds the slope of a tangent line. We call the slope of a tangent line a derivative. So let's just see how this is working. In this, you'll notice that I currently have a graph, and I'm currently looking at a slope of a graph. Okay? Now, if you think about x as a change, So as I'm approaching that a value, so as x approaches the a value, what I'm looking at is an a plus a delta x, where that delta x is getting smaller and smaller and smaller. Okay? It's just the slope formula, repeated again. Now, we're going to be taking a look, and if you haven't already seen the video, you should look at the falling object problem, because the falling object problem is another example of doing this process. Now, we're going to see one in just a moment, but I want you to understand something. There are two different concepts that we are going to work with when we begin. The first is something called an instantaneous rate of change, which is what this finds. The difference quotient finds an instantaneous rate of change when we use the limit. If, however, I just work with f of x minus f of a over x minus a, this is called just a slope and a rate of change. So once again, we're talking about a rate of change here, and we would refer to it in our class as an average rate of change. So anytime they're asking you to find an average rate of change, you are going to be working with the slope formula between 2 points. Don't freak out about it. Your job is to recognize what they want. If, however, they are asking you to apply the limit of the difference quotient, that limit as x approaches a for f of x minus f of a over x minus a, or, as I've already shown you, the delta x approaching 0 for f of x plus delta x minus f of x all over delta x at x equals a, is an instantaneous rate of change, also known as the slope of a tangent line at a, and is a derivative. So let's take a look at an example. Now I've got a couple, just very simple ones. So I don't want to make this too difficult, because if I do, life gets ugly. So what we're going to do is we're going to start off, and we're going to put f of a plus delta x in, and we're going to find out what is f of a plus delta x. And you'll notice we get 3 a plus delta x minus 2. Now, if I know what my a is, I can put that right in there, and I can say f of 2 plus delta x is going to equal 3 times 2 plus delta x minus 2. And we can now put this together. Now, keep in mind that we're talking about a limit. So we're going to start off with our limit statement, and you must have your limit statement until you evaluate, or you're going to end up losing credit, and I don't want that. So we're going to put in our 2 plus delta x minus 2. Notice that's our f of a plus delta x. We're now going to subtract f of a. I use brackets to make sure that I distribute correctly. It's something I don't want to have a problem with. I'm going to now distribute. Clean this up. Now, as I clean this up, we have practiced working with the difference quotient multiple times, so there shouldn't be any issues at all. Whoop, I forgot to put an a right in here. It is, after all, f of a. I then have minus 3 times the 2 value. The 2 value is the a, Mr. Lamb. Get that in there, please. There we go. So I've got my 2, I distribute, and I've got a plus 2 all over delta x. Now, everything that has no delta x should cancel. So I can now write it as the limit. Let's make sure you can all see that. As delta x approaches 0 for 3 delta x divided by delta x, and I find the limit is 3. This is telling me that the instantaneous rate of change of this function, 3x minus 2, at the value x equals a, has a slope of 3. Now, this makes perfect sense. Why? Because if you think about what a line is, a line that has the slope 3x minus 2. Let's stop and think about it. What is a tangent line to a line? Isn't it the line? So the slope of the tangent line at any point you might evaluate on a line is the slope 3. So if I were to do this and knowing this situation, if I were given a new function, let's say f of x equals 5x minus 2, and I ask, what is the limit as delta x approaches 0 for 5, let's do 3 plus delta x minus 2, and then we have to subtract and we divide by the delta x. This little piece is minus 5x plus 2 here. That has to have a slope of 5. And if you go through all of the work, we distribute, we add our like terms, you'll notice. Oops, and once again, I've got to put that 3 in. 15 minus 15 are going to cancel. The 2 minus the 2 are going to cancel. I'm looking at 5 delta x over delta x. The delta x's are going to cancel, and it's the slope. So the first rule that you need to understand is that the derivative of any linear equation at any value on that line is the slope of that line. Don't make it hard. Don't make life difficult. You don't have to go through all of this work if you remember the rule. So remember it, because it's going to come back over and over and over again for a long time to come. Thank you very much. I hope this made sense and will help you with your homework. Please continue to practice. You need to practice your difference quotient, and you need to practice your limits of the difference quotient. We're also going to be working with a lot of rates of change. Not because you can't do it. I know you can make slopes, but you need to remember it. So when they say, find the average rate of change, you know you're using the slope formula. If they say, find the instantaneous rate of change, or find the derivative, or use the difference quotient in order to find yada, 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 I need you to remember that that is finding a derivative, the slope of a tangent line. And to do that, we're using the difference quotient. Eventually, we will learn that there's a pattern, and that pattern will set us free. We will be set free from the bonds and shackles of our calculus overlords. Thank you very much. Be safe, be well, and take care. Thank you.